Let's continue with our lesson today for module 10. This is lesson 1, sorry. Lesson 2. Oh, okay, lesson 2, yes. Okay, got it. Okay. Okay. So, semua orang boleh dengar? Boleh nampak screen? Can you see the screen? My slideshow?
Yes, Doctor.
All right, thank you. All right, this is the second part of non-metal, non-ferrous material. Again, the objective of this module is you should be able to describe general properties of magnesium and its alloy and site their application, describe general properties of titanium and its alloy and site their application, and as well as the nickel. Okay, and if we look at the structure of metal and the alloy, non-ferrous, we have copper and aluminum. We have discussed in the previous class, and the next we are going to look at other metal, which is non-ferrous metal. There are magnesium, titanium, as well as nickel. The other non-iron based metal that classified as non-ferrous metal are magnesium, titanium, and nickel alloy. Okay, and the pure magnesium is silvery white metal that ignites easily in the air and burns with a bright light. Okay, if you look at the physical properties of magnesium, most likely it is a white powdery surface. White powdery means that it won't be a shiny silvery white structure. It is a pure magnesium. Okay, what you can see is it is pure magnesium, fresh, extracted from its metal ore. Immediately it will, the melting point is very low. And immediately this metal will be react with the oxygen from outside, water or oxygen, and it will, we call it burns, meaning that it is isotropic process. It will generate heat, and the spark means that it will react immediately with the oxygen, forming a very fragile oxide layer. Okay, oxide layer of magnesium. So what you can see, it is a very fragile porous structure. It is not like aluminum oxide. Aluminum oxide is very compact and continuous layer, but this oxide layer of magnesium is similar to the oxide layer of iron. Okay, the oxide layer of magnesium similar to the oxide layer of iron, which is a rust. Okay, rust. Dia macam karat lah. Karat dia tapi color dia warna putih. It is a white powder. Okay. So it means that once you expose the pure metal magnesium, it will burn with a bright light, and then it will form a white powder. Okay, this is pure magnesium. Okay, once you expose to the air, ini maybe dalam what we call it in a control condition. Okay, after some time you can see a white powder form on the surface. And in terms of the lightweight, it is better than aluminum. The density is only 1/3 compared to the aluminum, but the amount that we can extract from the metal ore is not as much as aluminum. Aluminum is the largest contribution of the non-ferrous alloy materials. The yield strength, it is about 20 megapascal with the tensile strength about 82 megapascal, which is very low compared to the steel 200, minimum 200 or 300 megapascal. Okay, elongation of 6%, and hardness is about 30. So if we add a different alloying element, it will produce different effects to the performance of your magnesium based a lot. So for example, like you want to add aluminum, okay. The good things about this alloying element is it is increase the hardness, the strength, castability, and slightly increase and by having these good properties, which is hardness, strength, and castability, you still can maintain the lightweight. Okay, the properties of lightweight you still can maintain because aluminum also considered as a low density material. And then for the zinc, the second, if you use zinc as a second alloying element, not second alloying element, the second element in your alloy, it can increase the fluid ability during the casting process. And sometimes we add other third and fourth elements such as iron as well as nickel. And the purpose, if we add nickel iron alloying element, it can improve the corrosion resistance. And the manganese, okay, if we add manganese in magnesium, it can increase corrosion resistance also, okay, especially in the salt water, okay. And the silicon, basically we add silicon purposely to if we have a component that require a casting process, and besides it also improve the melting point, okay, the stability at high temperature. And if you can improve the melting point and the stability at high temperature, meaning that the material are stable and resistant to the creep, because creep basically occur at the temperature of 1/3 of its melting temperature. And when we talk about creep basically a failure that occur on a structure if we introduce a constant load at high temperature. Okay, even though the load is a very minimum, maybe not reach the yield strength of the material of the alloy, but if it's combined together between constant load and the temperature, you will promote creep failure to the materials. But if you add silicon, you can improve the resistance to the creep failure. And if we add copper in the magnesium, okay, the good thing is it so can improve the stability of both room and high temperature strength. Okay, you can maintain the strength at the high temperature. If you add zirconia, you can refine the grain in the sand and gravity casting process. Oops. Okay, so the magnesium alloy have even lower density than aluminum. Okay, because the density of magnesium itself is 1/3 of the aluminum. Magnesium alloy exhibit especially high strength to density ratio or high strength to weight ratio. Magnesium also have relatively poor resistance to creep, fatigue, and wear, okay, compared to the other alloy. And pure magnesium and its alloy generally exhibit only limited ductility at ambient temperature because it has a ACP crystal structure. The magnesium alloy offer the potential for weight and related energy saving in both the automotive and aerospace industry, as they have the highest strength to weight ratio of common structural materials. So remember, if we look at the whole production cycle of any product, we are not just focusing on the function for a specific component, but we look at the total cycle of production. For example, like if we want to produce automobile if you want to produce a car, for example, okay, we look at the total total function of the car. For example, like this one, we are not just focusing on the strength to the weight ratio, but we're focusing uh, um, on the related to energy saving. Okay, because of the lightweight, uh, it can produce a total weight of the car so much so that the energy required to move the car is less, so that we use less fuel and it will produce less carbon footprint. So this is a good thing about magnesium. Okay, this is an example of the product made of magnesium alloy. It is a cylinder block for expensive car, which is BMW, and the outer case. Okay, the outer case is made of magnesium alloy. Okay, weight reduction effect expected by using magnesium alloy for automotive component. For example, the cross carbine, the bracket, battery cover, okay, seat frame. Of course, it is not like for the structure that experience cyclic load, mostly for the static load. Okay, which is the amount of material is huge. If for example, like the frame of this car seat, okay. Uh, so compared to the shaft, which is shaft is experience cyclic load, and the amount of the material is not so much, but it is okay if we use it for a high performance material, plus slightly heavier than, not slightly, which is heavier than the magnesium, but it's still okay because it's require resistant to cyclic load and fatigue failure. Okay, other application of magnesium, it is quite wide range application in consumer product. For example, for tennis racket, to suitcase frame. And then next is titanium. Okay, titanium is a light metal. It is almost double to, not really double, but almost double to the aluminum. But the strength is higher than, of course, higher than magnesium. And titanium has crystal structure of HCP at ambient temperature and transform to BCC at 890 degrees Celsius. So titanium metal is brittle at room temperature. It becomes ductile at high temperature. Okay, so this is the physical appearance of pure titanium. So titanium has excellent resistance to corrosion. They form passive oxide film which make it resistant to corrosion. Okay, remember, metal will always react because it has a electron C that freely move inside the metal. So once it's on the surface, okay, remember we have the positive charge of the metal atoms, and we have the free electron. So the electron will easily react with the environment, forming an oxide layer. So this oxide layer, okay, let's say if it is iron, so oxide layer is iron oxide. If it is titanium, so meaning that oxide layer is titanium oxide. So the thing is, we need to design, okay, we need to choose the correct materials. Okay, they define materials is corrosion resistant if the oxide layer is based on the characteristic of the oxide layer. For example, if the oxide layer is forming a strong continuous passive layer, we call the material as corrosion resistant material. For example, like a layer, if we have iron plus chromium, and if the metal exposed to the oxygen, it will form chromium oxide instead of iron oxide. So meaning that the material is corrosion resistant, such as stainless steel. Okay, understand? So the metal, whatever the metal, the definition of corrosion resistant is the oxide layer formed when it is exposed to the oxygen or when they transform themselves into an oxide layer. The characteristics of oxide layer are different from one metal to other metal. Iron oxide, magnesium oxide is non-passive layer because they are the physical structure is very poor. It cannot form a continuous layer and a stable layer to protect the base material from further reaction with the environment. So the titanium is also possess high fatigue limit. Commercially, pure titanium has proven its suitability as an important material for bone and dental surgery. It is widely applied on that particular application. Okay, for example, the titanium screw used in a spinal fusion surgery, and for cheaper material, we use stainless steel. Basically, for cheap material, we use stainless steel. Okay, if you have more money, you can request more expensive material, such as the titanium-based material. And when we if we look at the phase diagram of titanium, you can see there are several phases of titanium. One of them is alpha titanium. Elements such as aluminum, nitrogen, carbon, and oxygen. This element, if you add a small amount of this element, it can stabilize the HCP electrode and increase the temperature at which the HCP transforms to BCC alpha titanium. So meaning that, for example, let's say this is the phase diagram of titanium. Okay, you can Google the phase diagram of titanium. For example, this is a phase HCP phase of titanium. This is BCC stable titanium. So alpha titanium is titanium. If we add this element, it will widen this region. Okay, so meaning that the limit, temperature limit, this is temperature versus composition of titanium alone. Okay, it can shift this initial limit to the higher transformation limit. So meaning that you can stabilize the HCP structure at a higher temperature. So meaning that the application of titanium, if you add this element, it won't change the rigidity, the original properties from rigid to soft. This one is soft because of BCC, and this one is rigid. Okay, rigid structure. So meaning that you can maintain the mechanical properties for a higher temperature application. How? Just by modifying the phase diagram. How to modify the phase diagram? You need to try which element can really stabilize the HCP structure. So addition of aluminum further reduce the density of a lot. Alpha titanium is stronger yet less ductility. Okay, less ductility due to the HCP structure. Okay, in HCP structure, remember it is less ductility. It is not soft because of the slip plane is only 3. Okay, only 3 slip plane. It cannot be hardened by heat treatment. Okay, and the application of alpha titanium is you can apply. Okay, titanium, for example, titanium 5%, aluminum 2.5%, titanium, which available commercially in many forms. They can commonly use in frame and jet engine application. Okay, the frame body of the jet engine. This alloy has good weight ability, stability, and strength at elevated temperature. But of course, it is expensive. Okay, another titanium alloy we call beta titanium. Beta titanium has vanadium and molybdenum alloy element that uh, contrast to the alpha titanium. This vanadium and molybdenum stabilize BCC crystal structure. You can achieve this BCC crystal structure at lower temperature. What does it mean? It means that, for example, this is the phase diagram. We always look at phase diagram. Okay, if we want to um, uh, look at the fundamental of alloying system. Okay, temperature versus weight percentage or composition. Okay, let's say this is the region between HCP and BCC. Okay, BCC first diagram. So if you add vanadium and molybdenum, this alloy element will reduce. Okay, it will reduce this limit to a lower temperature. So you can have the ductility for any purpose, for example, for processing purpose or whatsoever, at lower temperature, so that you can save the time. Maybe the application of this material, which is beta titanium, is only focusing at lower temperature, so that you require some processing method. So you need these soft properties. Okay, so to obtain soft properties, you don't need high temperature, because you add vanadium and molybdenum, it will lowering the limits of temperature to change from HCP into BCC crystal structure. So beta titanium is the more ductile phase due to the larger number of slip plane in the BCC structure. This titanium alloy has an excellent formability and can be easily welded. So the application of beta titanium, for example, this commercial name beta 21S titanium is a high strength, heat treatable, metastable beta titanium alloy. It is engineered specifically to improve resistance to oxidation and creep along with enhanced elevated temperature strength and stability. Okay, beta 21S plug and nozzle assembles for this kind of engine, Airbus A340. Okay, the X3, this is other application, mostly for aircraft application. Why? Because it is high corrosion resistant and lightweight. Okay, lightweight. So another famous titanium alloy is titanium 6 aluminum 4 vanadium alloy. Okay, it's combined alpha and beta titanium alloy. But remember, vanadium is to stabilize BCC structure and aluminum to stabilize HCP structure. So it's combined these two microstructure. Okay, this alloy is the most extensively used in titanium alloy since it's combined high strength with workability. So this is the most famous right now. Okay, the tensile strength of this alloy in the solution heat treated and age condition can reach 1173. Okay, berapa banyak dia improve tu daripada pure metal. Okay, and then the implant and prosthesis application, additive manufacturing, parts for aerospace industry used extensively within the Boeing 787 aircraft, marine application for utilizing the corrosion resistant, chemical industry, gas turbine, firearm, silencer. Okay, when we talk about implants, the good things about titanium is because some of the mechanical properties, unlike stainless steel or other alloys, it is almost similar with the bond structure. Of course, magnesium and other materials also can, but We talk about permanent, not permanent, permanent. Okay. For the long-term terms implant materials, titanium alloy is the best. Okay, in terms of the close mechanical properties to the bond. Okay, there are links here. You can search the more information about the titanium alloy. So the general properties of pure nickel. Next is pure nickel. If you search about pure nickel, you can see easily obtain the properties of pure nickel. Okay, nickel has exceptional resistance to corrosion and high temperature oxidation. It has good strength and electrical conductivity, and nickel has the FCC crystal structure, and therefore it is ductile. The nickel is an expensive metal which is limits their use. Okay, this is example. Okay, nickel. If you ask me about the application of nickel, it is actually mostly being used as coating material. Okay, coating material. As a base material, mostly it is being used for the turbine blade. If you look at this, okay, this turbine blade, the base material, mostly they use nickel alloy, but the reason they chose nickel alloy because nickel is one of the famous material for super alloy. Okay, it has the best performance for the strength if the application require cyclic load. Okay, okay. So other than nickel super alloy being used as a in the bulk material, mostly nickel is being used as a coating material. Okay, mostly pure nickel, and sometimes they use not composite alloy, which is nickel phosphorus. This is the most famous, and second is nickel boron. Okay, some kind of alloy where the inclusion of alloy element is a light material like phosphorus. Okay, so nickel is widely used for coating. Mostly in the electronic component actually. Electronic component, for example, on the printed circuit board, we have a nickel coating. Why they use nickel? Because if you look, I think in Malaysia there are a lot of semiconductor company. There's a huge number of nickel coating process in Malaysia. In fact, in Johor, I think, in fact, in the Johor Bahru itself, area Iskandar Putri, I think 5 until 10 company dedicated for nickel coating for electronic component. Okay, and the plant is quite huge. One tank for nickel solution, I think, 500 liter until 1,000 liter. Okay? It's a quite high rate production, and Malaysia supply all over the nickel coating for all over the world. So this is the application of nickel, mostly on the coating, especially in Malaysia. It is truly dedicated for electronic component. And why they use nickel coating? Because electronic circuit board, it has a copper for conducting materials. So we have copper layer on any composite or polymer substrate or whatever. If you open your electronic devices, you can see a green board, which is a printed circuit board. Okay, on the board, which is sometimes made of a composite, made of a plastic, like a board. Okay, like a wood. You can see it seems like a wood. Sometimes it is polymer. It is being coated. The board is being coated with a copper layer. And this copper basically we solder with soldering material. Okay, so mostly the electric conductivity between these two interfaces is weakened over the time, even at a normal room temperature is weakened. So most of the copper surface is being coated with nickel. Okay, being coated with nickel, and most, I think now the coat is nickel because to enhance the reliability of the joining. Okay, any electronic component will be joined. For example, there's one electronic component here joining to the printed circuit board. We have the solder material, the stannum plumbum or plumber free stannum solder. Okay, so it's a huge. All the electronic packaging, electronic component has these structures. Copper for conducting electric over the board, connect one component, electronic component to other electronic component. So they are solder material. So the solder will be weakened without nickel. So most of the copper substrate being covered by nickel to further enhance the reliability of the joining for the electronic component. So it's quite normal application of nickel as a pure nickel phosphorus or nickel boron for a coating application rather than as a bulk material. However, okay, there are exceptions for some kind of alloy, okay, for nickel. We call it a super alloy. Other name famous nickel alloy, we call it Monel. Monel is a group of nickel alloy. It consists of nickel plus copper, okay, where the majority of elements in the alloy is nickel. So we call it nickel-based alloy. Even though the portion of copper is about the same with nickel. Okay, by adding 32% copper, you can really promote the strength of the alloy. Okay, Monel corrosion resistant make it ideal in marine applications such as for the piping system, pump shaft, seawater valve, trolling wire, and a triangle basket. Okay, so in the because of the corrosion resistant, so we can use for joining the structure. Joining means that joining by fastening, not by welding. Okay, if you have two component, for example, this is the tank and this is the piping system for joining between this junction made of strong and corrosion resistant material like Monel. Okay, so the application in the salt, acid, and alkali environment is suitable for this kind of alloy. And other than Monel, we have, you can search other famous nickel alloys such as Inconel. This one is famous super material. We call it super alloy. Expensive car, if they want to use, expensive car with a turbo. You always heard about turbo, right? So basically, it's driven by turbocharger. Expensive car, sometimes they use Inconel best material for the turbocharger part, so that it's stable at a high temperature. It can minimize the heat loss, so that it really utilize the energy. Whatever energy required to operate the car or to fasten the car. So this is nickel alloy, and one of the alloy we call it super alloy. And of course, in Cornell, mostly they use for the high cyclic load applications, such as for the turbine blade. Okay. So magnesium, in summary, I can say that magnesium alloy are exceptionally light and used a lot in aerospace and automotive application. Titanium alloy have a combination of strength and lightness that is not available from any other metal alloy system, and they are used extensively in aircraft or shop parts because of the lightweight. And nickel has a high corrosion and oxidation resistant and are therefore commonly used in the oil and chemical process industry. I think that's all for non-ferrous alloy. Do you have any questions?
No question ada.
No question. Okay. So the notes is very short, light, but you can further find information about non-ferrous alloy other than uh, the one that listed in the notes. Okay, we have a lot of material. We have chromium, we have platinum, we have gold, we have silver. There are a lot. Okay, and in fact, due to the development of nanotechnology, some of the rare earth elements also being used as a main materials for the industrial application or for the engineering application. So it is very interesting if you look at the application of non-ferrous alloy other than these five alloy listed in the notes. Okay, the function is very unique for solar cell, for fuel cell, all the new technology nowadays. It is very interesting. It is very critical study technology so that it can perform very outstanding whatever the purpose is. So if you have time, you can explore by yourself. Since you have no question, I think that's all for today. Uh, we will continue our class for tomorrow and focusing on discussing our assignment, which is group assignment.